Welcome to part 2 of the Building Science for Dry Climate video series with Franklin Energy. In this video, we're going to look at typical weatherization measures and their development from past to present. We are also going to look at contractor safety and the role that quality control plays when a company begins the transition into building performance and the application of real building science into the way that they approach each scope of work. Be sure to watch the other videos in the series, as they are designed to help you understand the various topics individually, but are intended to inform your approach to energy efficiency retrofit work as a whole. The categories you see here are all interrelated, and when used together, guide your analysis of what a house really needs and improve your ability to deliver a scope of work that effectively, efficiently, and affordably delivers a comfortable and safe home to your customers. The focus of this video will be the weatherization, worker safety, carbon monoxide, and quality control. For this first portion of the video, we're going to look back at typical energy saving measures that were developed and refined by the U.S. Department of Energy and weatherization agencies across the country from the late 70s to the present. Some private contractors became early adopters of these energy efficient practices and began to package and sell similar scopes of work in their business model. What emerged became known as the building performance contractor, and today, many of the utilities throughout the country provide funding for both types of programs, the low-income weatherization assistance programs, as well as a rebate or incentive program available to for-profit contractors to encourage or incentivize their customers to replace older appliances with more efficient equipment and improve other of the home's energy wasting features. One of the keys to this low-cost, high-return approach to energy savings is to focus on the exterior shell of the building. We use tools like the blower door to assess if a particular home is a good candidate for air sealing measures. Air sealing, combined with added insulation, have dramatic effect on a home's comfort, reduced energy consumption, and even indoor air quality. Some other measures could include repairing and replacing primary windows, doors, simply weather stripping doors and windows, and even looking at installing reflective films, solar screens, or even awnings to prevent unwanted heat from entering. While attic insulation is much easier and a more common fix, drill and fill wall retrofits can provide cost-effective solutions on older homes, and if done correctly, can provide both the desired R values and reduce air infiltration through the wall cavities. Dense pack sidewall insulation is only as effective as the installation itself. Practicing on a wall prop like this one helps installers get a feel for the work, like when to pull the hose down or how to probe those cavities and so on. Building science has tested and proven this method, giving us the target density of about 3.5 pounds per cubic foot, where at that density, the insulation is dense enough to stop shell leakage through those wall cavities. And for an educational video series like this that includes safety, it's important to recognize that the images used don't necessarily reflect our ideas and appropriate or about appropriate workplace attire. Many of these images are taken from the Department of Energy's weatherization website and are meant to illustrate the practical side of doing the work. But you can tell many of the pictures are over 20 years old and don't include typical PPE like seen today, safety glasses and boots. Laying plastic on the ground before a drill and fill job makes cleanup much easier. It's a critical step in the home, or if the home has lead paint. It's also a good idea even if the house doesn't require that specific lead-safe weatherization practice. Notice the removal of a particular course of siding. exposing a more opportune place to drill into each stud bay from outside the home. Some contractors drill on the interior and then patch and paint the sheetrock. The drill bit used for drilling holes in the siding is sized to fit the hose and allow a little movement for probing around the cavity. The hole is too large for the hose, and cellulose blows out around the hole, making installation more difficult. But I gotta ask, where's this guy's safety glasses? Holes are drilled in every stud bay. Bays can be filled from the top or the bottom. Filling from the bottom allows you to work from the ground instead of from a ladder. This is just an example of one type of building shell measure. Moving away from building shell specific type measures, here we see a list of typical mechanical measures: cleaning, tuning, repairing, or replacing heating and cooling systems. We encourage contractors to consider downsizing equipment after shell measures like attic insulation have been implemented. Sealing existing ducts or modifying duct systems so heating and cooling systems operate efficiently and effectively. It's common to increase return duct capacity to increase airflow and reduce static pressure. Insulating the ducts saves energy by reducing heat loss through conduction of cold ductwork. And moving away from some of the old rules of thumb in the HVAC industry, like system sizing and duct design, is an important part of the transition to becoming a building performance contractor. Running a manual J for heat load calculations will tell you what the house and individual rooms really need. It takes out some of the guesswork that usually leads to oversizing of equipment. In the low-income weatherization assistance programs, where replacement is typically not an option, equipment tune-ups often include cleaning the fan. Dirty fans are less effective at moving air than clean fans. Cleaning the grill of this window AC unit is a low-cost measure and improves efficiency of that unit. Sometimes a measure could just be a thorough cleaning. Clean air filters allow better airflow. When the air handling unit can move air more easily, performance is more efficient. Surprises are sometimes hiding behind dirty filters. This is the same return seen in the previous slide. At some point, the size of the return was so reduced that the air handler was starved for air. While this type of scenario is unlikely, it reinforces the importance of a thorough assessment of the home when you get there. Dirty ducts don't significantly affect airflow, but will pollute indoor air. Indoor air pollution irritates things like asthma. Simply cleaning ducts like this can improve the health and safety for occupants. Duct modification is another simple and effective, though sometimes unpleasant, energy-saving measure. Note that the connection of this duct to the trunk line or plenum, it looks as though it was just kind of shoved into the hole. Mesh, tape, and plastic applied properly can create a tight seal. Now, we're not trying to use duct tape. Properly sealed ducts keep conditioned air in the home. Duct sealing is largely out of sight, so the appearance of the mastic is not important, but creating a long-lasting, tight seal is the key. It's better that the seals are proper than pretty. Seal any part of the duct that can be reached. Every seam and juncture counts. This level of detail is more common now than even a few years ago, especially in California with our increasingly strict code requirements for duct sealing. Other popular weatherization measures might include installing programmable thermostats, repairing or replacing water heaters. Been doing things like faucet aerators and low flow shower heads really reduce hot water loads. Even considering an insulation blanket around hot water tanks, and definitely heating hot water pipes. While this has by no means been an all-inclusive or exhaustive list of measures, It was intended to expose you to some of the common measures used in the weatherization industry, because they've proven to provide significant reductions in energy bills with a relatively low investment of labor and materials. Typical weatherization measures address the building shell, mechanical systems, and base load measures. The effectiveness of dense pack sidewall insulation relies on the quality of the installation. And treating a mechanical system includes treating the appliance, the distribution system, and its exhaust. Let's talk about safety. Crew leads and field workers alike must possess a working knowledge of regular OSHA regulations that pertain to that particular type of work. They also need to know the PG&E specific or programmatic expectations, which link to other work practices like lead-safe weatherization, asbestos, and others. Being aware of how the hazard communication standard works and the importance of material safety data sheets, as well as the transition to the new template being used, the safety data sheets, the kind of loss of the M. We'll talk about that more briefly here later in this presentation. And lastly, the PG&E Make Safe requirements is a set of recommendations for dealing with natural gas leaks. And participating contractors in any of those PG&E programs are required to understand and follow their specific steps to take when gas leaks are discovered. Typical OSHA standards that apply to construction often include ladder safety and fall protection, training on how to use and maintain personal protective equipment, basic hand and power tool operation safety, even things like fire prevention, and even coming into the energy efficiency residential world, we're seeing trends leaning toward confined spaces, not necessarily permit required, but understanding the real recommendations around confined spaces and other work-related OSHA standards. Field workers really need to be trained in areas including how to select and fit, use the appropriate PPE, especially when it comes to respirators, how to safely use basic hand and power tools required for their job description, how to use basic first aid and how to maintain and access the first aid kits to treat common job site injuries, working lead safe, meaning you're careful of not only your workers, but also of collecting all of the lead chips and disposing them properly, how to identify serious mold conditions, and in general, just assess work area safety. As contractors get more engaged in building performance and the whole house approach, they often add new measures into their own scopes of work or subcontract it out to specialists. It's critical to understand the changing safety needs when you experiment and add new technologies to your work scope. PPE is for your benefit. Across the industry, when you talk to the older workers, their major regret is that they're now paying the health penalty for being tough and not using those disposable units and taking better care of themselves. Insulation, particularly recycled fiberglass, can be an allergen. While a person may not react to insulation at first, he or she will react once their personal tolerance level is exceeded. While this slide includes steel toe boots as part of a required PPE list, use your judgment. Again, we're using some slides that are part of a larger national archive, so oftentimes they include things about best practices. Whether or not your field workers wear steel toes is up to you. It's much more important that you take in the information, begin to assess how your company can elevate its game. How much mold is okay? Well, obviously, there's potential here to greatly improve the indoor air quality in these homes by proper repair of the water issue first and the damage it created. Whether or not you handle mold issues like this in-house or bring in specialists, proper respirators and mold remediation practices are expected. Come on, it's okay, you could admit it, we know. Many of us have made it through the day like this before, but investing in safety and creating a culture of safety where this type of fix is not the norm, not even to get to the end of the day, it's critical in improving the way your company approaches safety. We're all aware of the requirement to maintain an MSDS log and have it available to our employees, but also be aware of the transition occurring to align our hazard communication standards with the globally harmonized system for chemical manufacturers and distributors. This transition includes changing the MSDS format to a more standardized SDS, or safety data sheet format. It also incorporates the use of pictograms to communicate hazards. Carbon monoxide. Why does carbon monoxide play such a big role in the energy efficiency retrofit game? Well, it has a lot to do with the unintended consequences of air sealing leaky houses and repairing ductwork. In our efforts to improve the home, we often change the way the normal pressures in a home can affect other appliances. Tighter homes often result in greater depressurization, even when just the typical exhaust fans are running. Tighter ductwork can create greater pressures room to room and are known to depressurize the main body of a home, or at least the parts of the home affected by the return air. The building performance industry adds an additional layer of safety by testing for these pressures before you start work and especially after the work is complete, to ensure that all of the home's gas appliances are running cleanly and that there's no backdrafting, even under the worst case depressurization that the house could possibly create. Lastly, while small concentrations of moisture and combustion byproducts like carbon monoxide used to naturally ventilate out through a leaky home, once you have air sealed a home, those contaminants can potentially build up inside and create new issues. That's where all of the parts of this video series converge. We'll talk about the building science mantra, build tight and ventilate right. Building science looks at the house as a system, and we measure and test for results that show that our work has delivered the energy savings and ensures that the house has none of these unintended consequences that might have an adverse effect on the home or its occupants. Here's a table that shows us the different effects of carbon monoxide on humans at increasing levels of concentration. Small amounts over a long period of time can still result in health issues. 50 parts per million is the OSHA cutoff for allowable concentration in the workplace. In the energy efficiency world, anything above 10 parts per million usually starts to raise some eyebrows, and 35 parts per million might be enough to create a stop work order for your policies. PG&E has adopted the guidelines created by both BPI and NGAT to govern their combustion safety protocols. We'll cover these in more detail in a different video, but it's critical that contractors understand the dynamics of combustion safety testing and how to make it part of their scope of work. It is likely already a code regulation in your jurisdiction to include carbon monoxide detectors for just about any permit. The carbon monoxide detectors have been part of the utility programs for decades. Most of the utility incentive programs require that all projects require the installation of a carbon monoxide monitor. It's important that you always install the units that you have purchased to install, that you install them per the manufacturer's recommendations. You inform and educate the occupants on how to properly use them and maintain them, because most carbon monoxide detectors don't last forever. Make sure you educate your customers with the life cycle of the units that you're installing. And as a courtesy, write the date of installation on the back so people don't have to try to remember. In summary, when your company joins into a utility program, you're signing on to a commitment that includes compliance with not just typical OSHA regulations, but additional requirements of that program. Successfully blending the two will be key to your success in the program. That will include things like we see here: providing and maintaining and using the best PPE, maintaining good quality tools and keeping them in good working order, knowing how to follow all of the safety regulations, including installing carbon monoxide detectors for every project. And for your own knowledge or for the training of your employees, we've provided two very good outside sources to increase your awareness for ongoing trends as it relates to and training around carbon monoxide. Maintaining quality control. One of my favorite analogies to use when I'm talking with contractors about building performance industry is the story of my young son riding dirt bikes. How we started him off very young. He was about 4 years old, and how he progressed through the little guy bikes, and how as he improved, we rode harder, and rode trails and practice tracks. And soon we got him up on the bigger, faster two-strokes. He got better, and one day when he was about 7, he asked me to take him to the races. Now, I never raced. We were more out there to have fun. We had older, used dirt bikes that I could afford at the time, and yeah, we rode hard, but we were not racers. That became painfully evident when we got out to the track for the first time, and I saw dads out there with full race trailers, tuning bikes in between races, the whole 9 yards. It was like a baptism into a whole new level, and I realized there's my poor kid out there on a beat up used dirt bike doing the best he can with what we got. And even though I'm not a racer, I am a fan of racing, and I know that minor adjustments here and there can improve your times in the race. All that stuff can change the game. And that's what becoming a building performance contractor is like. It's taking the time to ask the question, how can I do this better? It's having the humility to be open-minded enough to hear new ideas, try new things, and test them so that you know if they work or not. As a building performance contractor, that's how we squeeze an additional 10% of efficiency here and maybe 7% more over there, maybe even just 4% over here. It's because we're paying attention to the details. We're searching for it. We continue to educate ourselves on how to find 3% here, a little bit more there, so that our efforts don't result in just the 10% that we got easily at the start. But maybe we got 25 or 30% more efficient because we paid attention to the details, just like those race dads were doing. Those other kids had a lot better machine than my kid had because those dads cared about performance, not just business as usual or recreational rides. Quality control is an ongoing process. It requires good attitude. It requires good tools. It requires constant vigilance. And I mean from crew lead down to basic new hire. And it requires you to check everything before leaving the job. It starts with preparation and organization. Always have the materials you need with you. Quality doesn't come from makeshift materials. See that the truck is clean when not in use and everything has its place. And let your crew know that each one is a valued member of the group. Valued employees do better work. Remember, it's the client's home. Train your crews to treat clients with respect. Find out what matters to them. It's much easier for your crew to do good work if the client is on your side. Show them that you respect their belongings. They'll appreciate it. Periodically check in with crew members as they work. Use the opportunity to commend good work and correct little errors before they're built in. Utilize diagnostic tools to test progress. Be sure the workload is evenly distributed and that all crew members work at a steady pace. One loafer can quickly demoralize an entire crew. Check each task as it's completed. Any necessary additional work can be done before the tools are put away. This photo shows an excellent, easily removable, insulated whole house fan cover held in place with either Velcro or magnetic strips. This can keep the heat in during the winter when the occupants are not using the whole house fan regularly. As it relates to quality control, look everywhere. This hole leads to this. Very uneven coverage of insulation. Even with the dams correctly done around the chimney and the recessed lights, this crew didn't even take the time to cover the customer's boxes and belongings. Not cool, guys. Not cool. In regions where adding wall insulation is common, train your crews to watch out for wall pops, which come from excessive pressure and from insulation machine and unskilled installers pushing too hard into the wall cavities. Be familiar with applicable codes. Spray foam is great for sealing pesky gaps, but it is not rated for the level of heat you get from a furnace flue. You need to use high temperature caulk or some other appropriate fix. Here, we see some of the diagnostic tools used in the energy efficiency industry. Clockwise from the left, we see a blower door setup. This tool can create pressure in a home that we can use to both locate leakage spots and also quantify the amount of the home's total leakage. The tool can essentially measure airflow through the white rings near the center of the fan while the fan's spinning. The blower door can also be used in conjunction with these other diagnostic tools, like the DG700 manometer seen at the top center. This is a gauge that simultaneously can monitor pressure created by the fan and calculate the airflow through the fan. There is a newer generation of this gauge called the DG1000, and we'll see that in other slides. A pressure pan, seen in the top right, is a simple tool you can use to locate duct leakage, comparing pressures in the home to pressures in the ducts with the blower door running. Infrared cameras are on the higher end of the cost spectrum, but have become much more affordable and can provide customers with graphic images of their home's hot and cold spots. A smoke generator seen in the middle on the bottom can also help us see subtle air movements and see which way air is moving and test for, things like the efficiency of an air barrier. All these can be used to guide your work, test the progress, and prove your results. The sensitive pressure gauges we use can be used with small tubed probes. We can compare pressures. With the house depressurized by a blower door, we can probe into various wall cavities, and if there's any difference in air pressure between the house and the wall cavity, then those specific assemblies or wall cavities likely have holes drilled through them at the top or bottom plates for plumbing or electrical, or could be some other larger undraft stopped utility chase, which are actually pretty common in older homes and are notorious leakers. Here's an example of a worker using a smoke stick to ensure that an attic insulation job didn't cover the eave vents. With the blower door running and an attic hatch open, the smoke will be pulled into the vent openings from outside, because that depressurization inside the house with the attic access open would also depressurize the attic, and it would draw that smoke right through those eave vents. But if the insulation had been installed and covered those vents, then that smoke wouldn't react to that pressure. Infrared is an amazing quality control tool because it visually displays surface temperatures and shows heat loss. It's very easy to spot voids in the insulation. This is what you might see on a cold day, where the well-insulated parts of the wall show warmer, lighter surface temperatures, and the colder, darker parts would indicate areas that had voids in the insulation or some other issue with a continuous thermal barrier. This is a winter condition. The darker lines you see are the structural members of a vaulted ceiling. You can see the uniformity of the insulation in the end wall to the right. You can also see the difficulty in properly insulating the rafter bays of a vaulted ceiling assembly. This is a summer condition. This is a great example of using infrared imaging and a blower door together. Through an infrared camera, you can easily see the hot air being pulled from the attic into the room and at the wall to ceiling joint by a blower door. The white ring at the upper edge of the picture shows hot air from the attic being pulled in around a poorly sealed recessed light. Zone pressure diagnostics is another way of testing the effectiveness of an air barrier. And the testing is done in conjunction with the blower door running as well. And with your probe and manometer, you can check for pressure differences between different zones in the house, like in this picture, between the conditioned space of the home and the attic. You can also check places like between the house and the garage, and even the house and the crawl space. A pressure pan is a simple device that can be used in conjunction with the blower door as well, and it can assess the condition of the ducts. With the blower door running, you depressurize the house to -50 pascals, and then you can compare the pressure of the individual duct runs with reference back to the house. In a perfectly sealed duct system, there would be zero difference since all of the ducts are open back to the house. And when you find a register that shows a difference, it indicates a connection with the air in the attic. The numbers mentioned here are more realistic on a house that's already been sealed. Most houses that I've tested actually have had 5 pascals in multiple registers. That's how you locate and can kind of find which of the duct runs are in the worst condition. I've even located ducts that were completely disconnected in the attic before I ever even crawled up there. And this quick trick won't quantify your duct leakage like a duct blaster, but it can definitely give you and your crew an accurate estimate of the overall condition of the duct system, and also inform your visual duct inspection as to where you should focus your duct sealing in the attic. Any real world test is preferable to a theoretical calculation. And as we move toward code requirements for mechanical ventilation, accurately measuring exhaust fan flow will become more and more important. And with this device, the fan flow meter, you will know that the fan your crew installed delivers the required cubic feet per minute of airflow. Here we see some of the common combustion appliance inspection tools. At the top, we see an inspection mirror used to look in hard to see places, as well as check for condensation and backdrafting. We see a yellow gas leak detector right below that. Allows us to use a sniff for gas leaks. A soap solution, which is hard to see, but I think it's the tube just above the mirror. It's important that you think of the gas leak detector as a way you can sense anything, and then a soapy solution is how we actually test to see if there's any significance to the duct. If it bubbles, then you got a problem. Might include a long lighter, for relighting pilot lights if needed, pipe wrenches, and also a combustion analyzer. This one's the back rack. We use this for testing flue gas and other combustion appliances for carbon monoxide. I know I started this last segment with a silly story about my son's dirt bikes. I appreciate your patience. I know it had nothing to do with fixing houses, but it did have a lot to do with how we see ourselves and how our willingness to change is key in staying competitive. And that resonates a lot with many facets of life, but it's especially true when we look at our business model, our workplace culture, and the expectations that we have on ourselves and our crews. Even though in racing, the goal is to go fast, it's actually going fast in our industry that causes a lot of the installation deficiencies that are a big part of the problem. Going fast in our industry often leaves low hanging fruit on the energy efficiency tree that we could have addressed to make the house more efficient. Building performance is about quality, it's attention to detail, and looking at each home through the lens of a house as a system to see how all of the parts affect the others. Looking at quality control requires good planning before the job is started and an eye for detail once the work has begun. Letting your crew members know that they're valued and noticing the job well done. Includes correcting errors before they become serious problems, choosing quality tools and maintaining them properly. And when the job is complete, viewing the test out to determine that all the combustion appliances are working correctly and not spilling, that ambient carbon monoxide levels are below the safety thresholds, and that your attempted work at air sealing actually moved the needle and the house leaks less and it was successful. Thank you. And be sure to watch the rest of the building science videos and series. If you have any questions, please feel free to reach out to our team here at Franklin Energy.